Now we're going to take a look at filters for telescopes. And once again, a lot of this is going to be subjective opinion. So in other words, it's, one man's view of what has worked and what hasn't for him. Other people will have different views and opinions and experiences. So before we actually look at each individual filter, or at least a representative of each class of filter, I think it would be useful to briefly review a couple of important points from part one, partly for those who may have skipped part one and partly just as a review if it's been a while since you watched that video. The important thing to remember when thinking about filtering light is that light has different sources, and normally our eyes and our human experience on Earth until the invention of the telescope was primarily interested in the continuous spectrum. That's what objects radiate for just due to heat. And as you probably remember, this can be either a solid, a liquid, or a gas, and it is excited to emit light by temperature. Now, temperature can be anything as low as a degree or two above zero, all the way up to thousands of degrees. These objects obey what's called the black body law, which I won't get into. When you start looking at the night sky, you come into the area of emission spectra. Those tend to be things like low-density gases that are excited to emit light. And they produce light through discrete energy transitions. In other words, the spectrum, the emission spectrum, is a series of bright lines that, if you watch part one, I'm sure you will remember, include things like hydrogen lines, oxygen lines, sulfur lines, and so on. Finally, an absorption spectrum is just the reverse of an emission spectrum. It is a situation where something behind a cool, low-density gas is emitting light, and that light is passing through the cool gas. Once again, we are dealing with discrete energy transitions. As that light passes through that gas, it excites electrons to higher energy states, and that absorbs certain lines of emission, and those are called dark lines. Now, it is primarily emission spectrum that we are interested in when we're looking at galaxies, but when we're looking at nebula, depending on whether it's a bright nebula or a dark nebula, and examples are the Orion Nebula is a light, bright nebula, an emission nebula. The Horsehead Nebula, which is very near Orion, is an absorption nebula. And so we're interested in all of these. Okay, enough theory. Back to the practicality of filters. The first filter that I'm going to show is this neutral density filter, and it's primarily used for darkening or reducing the brightness of the moon. I'm going to show you what it looks like through this. You notice that it just gets darker. Notice that the camera, when I put this over the camera lens, let me try to do it in a slightly different way here. You notice what the image looks like there, and then when you take it away, how it really, the camera has to readjust. If I had it on a fixed exposure, you would see that in one position you couldn't see anything, and in the other position you could see lots of detail. So let's talk about how you put these in a telescope. Now, filters come in a variety of different types and sizes, but the two most popular for telescopes at least, are those that fit into an eyepiece. This, in this case, is an 1.25" eyepiece, and they simply screw in to the end of the eyepiece. If I can get it in there without cross-threading it. By the way, you become very adept at this if you're trying to do it at night and you don't want to go into the light where the that ruins your dark adapted eye. And then it just simply fits into the eyepiece holder like that. So that is an 1.25". Now, there also are 2-inch filters. And I have one of those attached to this 2-inch eyepiece. In this case, this is actually a blue. It's called an 80A, and let me show you down the eyepiece what it does to the color. These are often called planetary, and I'm just unscrewing it off camera here. And then this is what it looks like without. So this is with, this is without. So why would you want that? Well, some people have more success with these than I do. I have frankly found that these are often called planetary filters or color filters. And the moon filter, the first one I showed you, the neutral density, that one I have found very useful. It helps to, it actually improves the contrast of the moon, and it keeps your eye from getting dazzled by the bright reflections from the moon. I've had less success with these colored filters for planetary objects, and maybe that's partly because I'm more interested in deep sky than I am in planets, so maybe I just haven't spent enough time doing planetary observations. But for example, this one is called an 80A. Let's see if it will show that. Right here, number 80A, and they come in different colors with different numbers, and they actually come from a set of filters that were developed by Kodak, I don't know when, before World War II, that were called Ratten filters, W-R-A-T-T-E-N, and I had an uncle who was trained in photography. In fact, he had studied photography in New York, so most of this is from his talks he used to give to me about astronomy and photography and so on. The Ratten filters were originally developed for black and white photography, and they were used to enhance the contrast of color scenes in a black and white image. So if you've seen any of those great black and white photos, people like Ansel Adams and I forget the name of the lady who worked for Life magazine that during the war, their black and white photographs are stunning. And a lot of that has to do with the fact that they understood how to use color filters to get to good black and white. I've never found them that useful for planetary observations, but some people say it helps to enhance the bands of Jupiter, the dark spot, the surface features on Mars, and even the rings of Saturn. So if you get a set of filters, you can try them. I would suggest that you maybe try out a set of filters at a star party before you go and spend any money on them. The next kind of filter I'm going to show you is a nebula filter made by Mead. Now these are discontinued, they're no longer available. This is called the 908N, and the N stands for narrowband. I'll show you in the Mead catalog in a second what the passband characteristics of this one is. I would say this is actually the best nebula filter that I have. At least I see more with this than I do with any of the other filters. And when we look at the passband, you'll understand why. Once again, this is from the Mead Series 4000. I know it's hard to read that, but there is the filter, and you notice that it looks a little green in reflection, or blue, depending on how I turn it. There it's more green, there it's more blue. And what is happening is it is passing, actually, if you look at it straight on, it looks almost silver. So let's take a look at what it's doing for you and why I find this one to be, although a little bit expensive. I think I paid like $90 for this more than 20 years ago. So it's a fairly expensive filter, and as 1.25" filters go. And by the way, that neutral density filter, for example, I think you can buy them for about $13 to $15. And those colored filters are running about that same range. This is a page out of an old Mead catalog that's still listed, the 908N. And you'll notice that there is virtually no transmission in this central region. It only passes the one hydrogen line and a couple of O3 lines, oxygen 3 lines, and then up in the upper end, in the red region, it passes especially the hydrogen alpha line. And let me see if I can zoom in a little bit. You might be able to see that a little better. And because it has this dual characteristic and passes hydrogen alpha, which, by the way, is very useful in some nebula, O3 is generally the one that's the most valued for nebula looking or nebula visual. Now, everything changes when you do photographic. And understand, photographic film and photographic imagers like CCD devices and so on, they have completely different characteristics from the human eye. The human eye sees best in yellow and green light. And at night, when your eye is dark adapted, your color receptors are essentially turned off. So don't expect to see a lot of color in the night sky through a telescope. You will see some color with planets, but in deep sky objects, generally what you see is contrast, light and dark. And so the fact that all of the colors in the middle of the visible spectrum are being eliminated by this filter really doesn't make as big a difference when you're visually observing deep sky objects at night. This one is my favorite nebula filter. But before we move on to a few others, let me conclude this part by saying some people have real good success with nebula filters. This particular filter, I really feel like, and I looked it up a minute ago, it listed for $135 in 1998. But the sale price from a place in Oklahoma called Astronomics, which I think are still in business, was $89.95, which is what I paid for it. So now let's take a look at a few more of what are called nebula or sky glow or light pollution filters. By the way, if you want a really good article on filters for deep sky objects, I have found this one to be the most useful of all those I've found on the web. It's put out by the Prairie Astronomy Club. You see their web address there at the top, and notice it's a .org, not a .com, called Useful Filters for Viewing Deep Sky Objects. I am sure that if you put that exact phrase into Google, you'd find it, if not at the top, at least below all the ads that people pay Google lots of money to force you to look at before you get to what you're looking for. So this is a very good article, and it talks about a number of different types of filters as well as a few specifics, which we will use some of their conclusions at the very end. One of the filters that I have found somewhat useful is this light pollution filter. It's called an Eyepieces, and let me dig out the data sheet I printed out on this one. Okay, I bought this on Amazon. It's an 1.25" filter, and I will read to you a little bit from their overview on. It says, the filter is designed to block specific wavelengths of light, targeting those bands that are transmitted by artificial light such as mercury vapor and high and low pressure sodium vapor lights. By blocking this stray atmospheric light, the filter turns the sky a pitch black for enhanced contrast of bright and dim objects against the backdrop of space. There's a little marketing hype there, but it does work. In a moderately light polluted environment, which is where I am, this does improve the contrast of deep sky objects. So I find it useful. It was very inexpensive. I do not remember what I paid for it, but I know it was less than $50, maybe less than $25. At any rate, the Eyepieces, it's called the, let's see what it says here, LP125. There is the model number. The next filter I have labeled UHC. See if I can get it to focus. Well, maybe it'll do better on this. Yeah, notice it says LP. I think LPN, yes. I started to read through the viewfinder. LPN, and I think that stands for Light Pollution Narrow. And then 8286, and here is, let me see if I can open it. Okay, there's the filter. Zoom in a little bit more. And like the 908N, this one, it looks silver when you look at it. As you tilt it, you see that in some light it looks red, at other times it looks green. The reason is that it's blocking some light and reflecting others. And once again, I have found this one, the UHC filter, to be somewhat useful, though not quite as much as the Eyepieces and nowhere near as much as the 908N. So let me get the overview sheet out for that one. Okay. This one, it says by South Star, and it says on Amazon, at least when I printed this out, which has been weeks if not months ago, it's currently unavailable, so I don't know if this is still available, but it's called a 1.25 UHC light pollution reduction filter for observations of deep sky objects, the Orion, Lagoon Swan, and other extended nebula. Don't get carried away by the title. It works, but it will not turn a heavily light polluted sky with bad seeing conditions into perfect astronomy in the middle of the desert on the top of a mountain kind of views. It will help, but it won't. Don't expect miracles. It says this filter is perfect for observation of faint and low contrast deep sky objects. Significantly reduces light pollution, great for both city and suburban observation. And by the way, I should point out, some people think that you only need a nebula filter if you have light pollution. So if you go out in the middle of the desert on top of that mountain I told you about, by the way, that's near the McDonald Observatory in Fort Davis, Texas, in case you're looking for the place I'm referring to. These filters will actually help in that environment. In fact, I used that 908N filter on that Mead LX10 on a trip to Fort Davis years ago, and it worked very, very well. This is an Astromania 03 filter. I'll put it back down in its case here and set it back down on the table. And here is the spectrum of this. They publish it on their website. Notice that it only passes, pardon, bumping the tripod. Notice that it only passes a very narrow band of frequencies around 03, the oxygen. Now it also passes the hydrogen alpha line, which is right near there if I remember right. But nonetheless, this is known as the Astromania 1.25" 03 filter, produces near photographic views, yeah right, of the Veil, Ring, Dumbbell, and Orion Nebula, among many other objects. Okay, depends on what they mean by near photographic. If you mean those pictures you see by real good amateur astronomers on YouTube, no, it doesn't even come close. If you mean the average astrophotography like I make, yes, it does produce things near that. But I'm not an astrophotographer. I don't pretend to be. So don't expect miracles from this one either. But let me tell you something about these 03 filters that really makes a difference. They are super at enhancing the contrast of certain nebula, even in fairly heavy light pollution. So if you're in a light polluted area and you really want to see a dramatic difference with a filter, use an 03. Now understand, all you'll see is light and dark gray, but you'll at least be able to see the outlines of nebula, assuming that you have a pretty decent telescope and you're using it on a pretty decent lens, eyepiece. So let's talk about that for just a second, and then let me close all this out. This is the Astromania 2-inch moon and sky glow filter. Behind it is the emission or transmission graph, and it's called a moon and sky glow because it really should say moon glow and sky glow, because this is not a moon filter. It's not really so much for looking at the moon as it is to look at things on a night in which the moon is out and you want to eliminate some of the moon's glow. So I explained this more deeply in part 1, but don't be confused when somebody says moon in a filter. Read carefully what they're talking about. They may mean a neutral density filter, like the one I showed you earlier in part 2, or they may mean a moon glow filter like this one. At any rate, this one has also been fairly good. It's not one of the best. I bought it mainly because it was in a 2-inch size and it was affordable. It's not anywhere near as good as the Mead 908N, but it falls somewhere in the middle of the rest. So I don't remember what I paid for it. I got it on Amazon. So and this is the last filter. So let me briefly summarize. Broadband filters are generally intended to pass a number of wavelengths. They are best used in either in light polluted skies when you're looking at where there's not too much light pollution, and you're particularly looking at deep sky objects. Narrow band filters are better when you have more light pollution, or you are only interested in looking at the parts that will pass through the passband, like 03. Line filters are even narrower still than narrow band filters, and there generally are two kinds, the 03 filter and the H-beta filter. Now the 03 filter, some of them will also pass H-alpha, but H-beta is way out at the other end of the spectrum, and those are most useful for things like the Horsehead and California Nebula, where there is gas, dark gas in front of light behind. Most emission nebula, like the Orion Nebula, you want to stick with an 03 or maybe a narrow band, or even on less light polluted nights, a broadband filter. So I hope this is useful as kind of my take on filters and the ones that are useful. I think you get the basic idea. Neutral density filter, good for moons. Nebula filter, pretty good but not perfect. Color filters for planets, in my opinion, not really worth a lot of money. So I hope that if you haven't gotten much out of it so far, that maybe in another episode we can look at some astronomy software and then perhaps come back and look in depth at a telescope or two. So look forward to that and have a nice day.